All right, let's find the inverse of this matrix here. And remember, to find the inverse, we're going to have to use the identity. So we set it up like this. We take the original matrix A, which is 2, -6, 1, -2. Use the variables A, B, C, and D. Remember how we write those variables? We invert the order of A and B, so we write them as columns, A, B, and C, D. They're written as columns for this. And this is going to equal the identity, which is, for a 2 by 2, 1, 0, 0, 1. And we begin to create matrix equations. So my first matrix equation, I'm going to multiply this column, this row, by this column. So I get 2A minus 6B. Then take the same row and multiply by the next column, which is 2C minus 6D. Minus 6D. Second row, first column, A minus 2B. Second row, third column will be C minus 2D. Remember, I have two unknowns, but I have two unknowns with two equations, so I can go and use elimination to solve this. I'm going to eliminate the A variable here. So I'll multiply the bottom row by 2. I'll go ahead and get this out of the way, but I'll multiply the bottom row by 2. So I get 2A minus 6B, 2A minus 4B. And remember that I need to set these equal. This one equals 1. This one equals 0. This one equals 1. This one equals 0. Sorry. This one equals 0. This one equals 1. So I'm setting them equal to the identities. So when I do this, I have that equals 1. And this will equal 0. I actually need to multiply by -2 to make these signs flip. So when I do that, I get, A's are going to cancel. -6 plus 4 is a -2B. That equals 1 plus 0 is 1. So that means B is equal to a -1/2. And if B equals -1/2, I can go back and find A. I'll use this equation right here. A minus B is equal to 0. Minus 2B is equal to 0. So I'll plug in for B, which is 1/2. So I have A minus 2 times 1/2 equals 0. Half of 2 is 1. So I get A minus 1 equals 0. And A is equal to 1. So I know those values. Let's go find C and D now. So to find C and D, I will eliminate the C's. I'm going to multiply this row by -2. So I have 2C minus 6D equals 0. Then I have -2C plus 4D equals -2. These are going to cancel. -6D plus 4D is a -2D. That equals -2. Divide by a -2 on both sides, and D is equal to +1. Go back and plug in. I'll take the black equation because it has a single C in it. So I know that C is equal to, or C minus 2 times 1 equals 1. So I took this equation, plugged in for D, plugged the 1 in that I got here for D. And I see that C minus 2 is equal to 1. Solving for C, move the 2 over. Bring the 2 to this side, it becomes positive. That's 3. So with that, here's the inverse. We call it A inverse. A inverse is equal to, the A variable is 1, the B variable, -1/2. The C variable is 3. The D variable is 1. Now, a quicker way to find the inverse is going to be through what we call our determinant. And we're going to find the determinant of 2 by 2 matrices. So when we do that, to calculate this, here's how we set it up. If you have matrix A with A, B, C, and D, the determinant, and you can write it, it's written as determinant A, or use the absolute value bars around it, A, is equal to, you multiply the products of the extremes, A times D and you subtract off the means. That's what B and C are. So you're multiplying A times D and B times C, and you subtract off BC. That gives you the value of the determinant. Once you know the determinant, we can calculate A inverse by multiplying the determinant, which is a scalar, by you switch A and D and you negate B and C. So let's go ahead and try one of these problems. So the exact same problem we did up here, or on our original problem that we did, we're going to find the determinant of this 4 minus 1, negative 6, and 2. So to find the determinant of it, so the determinant of A is equal to, we multiply 4 times 2, and we subtract off negative 1 times negative 6. So when we do that, we get 4 times 2 is a positive 8 minus negative times a negative is positive, negative times negative is positive, then you have a negative sitting right here, so you're going to be subtracting a negative 6, and the determinant is just 2. Once we know the determinant, we can multiply this value by doing this. We can find A inverse. This is equal to, you do 1 over the determinant, 1 over 2. And when you rewrite your matrix, you need to flip A and D, or what we call the extremes. So this is going to be 2 moves here and 4 moves here. And you negate what we call our means, or B and C. So you're going to negate negative 1, and it becomes a positive 1. You negate negative 6, it becomes a positive 6. And now you just multiply by that 1/2, like a scalar. And we get 2 times a half, 1. 1 times a half, 1/2. 6 times 1/2 times 6, that's 3. And then 1/2 times 4, that'll be 2. In the original matrix that we did earlier, we got these exact same values for our inverse. So let's try to find the inverse of this matrix here. And it's a 2 by 2, so we use the determinant method to do that. Remember, with our determinant, we have the determinant of A. Determinant of A is equal to, we multiply A and D, so that's 1 times 6. We subtract off B and C. Negative 2 times a negative 3. Notice that when this happens, though, the determinant of A is actually equal to 1 times 6 is 6. These two together make a positive 6, so you'll have a negative sitting back there since there's 3 negatives. 6 minus 6 is equal to 0. So because the determinant is equal to 0, if we try to find A inverse, well, A inverse is set up as 1 over the determinant, so that would be 1 over 0. This right here is not possible. So it's not defined. Division by 0 is not defined. Because of that, the inverse does not exist for this particular thing, for this particular matrix. A inverse does not exist. And this is what we refer to as a singular matrix. A singular matrix.